Good morning. Today we are continuing on with those functions, and the domains and the ranges and all that wonderful stuff that we started this unit off with. Today we are doing CO48. I can identify a function given a graph or relation. So we hear that objective and we go, I have absolutely no idea what that means. And I look at you and I say, oh, that's wonderful, because I get to teach you. So it's good to look at the objectives and say, no idea. This is beyond me. And I say, yep, because we're getting into the challenging stuff where we actually are learning these new things. So when I see those faces that Michael is making, going, I don't know what that was, what did Ms. Gambino say? It makes me happy. Because by the end of the lesson, Michael's going to look at me and go, yeah, I got this.
Yeah.
No. Okay? So when we see the objectives, it's always a good thing when we go, I don't know what any of the words mean. Because that means we're going to learn it. I get to teach, and that's always fun for me. All right, first thing we're going to do, if we can identify a function, we need to know what a function is. A function is a relation where every x value has exactly one corresponding y value. So, to explain the function, we're going to use the idea of birthdays. Can two people, x, so let's say x is a person, can two different people, two different x's, have a birthday on the same day? And we have a perfect example of it in our room right now because David and I are birthday buddies. We share the same birthday. We are two different people, two different x's that can share the same birthday. So that birthday, the date is the y. But can one person, the same person, so let's say me, can I have two different birthdays? No, I can't. One x can't have two different y's. So you can have two different x's have the same y. Two different people can be birthday buddies. But that one person, that one x, cannot have two y's, two birthdays. Okay. So when we look at this, two different x values can have the same y value, but the same x value cannot have two different y values. So it's a function if every x value has only one corresponding y. If there is one x value and it has two different y's listed, then it's not a function. Okay, so we're going to look at all of our data that we're being given, and we're going to determine, is this a function or not a function? So let me scroll up. So a function table, when we have our x's listed, there is no duplicate x's with different y's. So I see 2 only one time for an x. The 2 matches with the 9. It doesn't match with a different number also. Okay, so the x's don't repeat with different y's. So 1, 8, 9, 12. Those x's are not repeating. Is it okay that there are 2 10s for the y's? Yeah, because that would be 2 different, they're 2 different x's. So this would be one person having a birthday on the 10th and another person having a birthday on the 10th. That would be our birthday buddies. So it's okay that multiple people share the same birthday. So that's a function. When we look at our graph, this is our x-axis. Every x just has one y coming off of it. What if I had a line like that also? Would that be a function? Think about it. If this is my x, and there's a line down here and a line up here, it's listing two different lines. So you have to really look that the x only has one y coming off of it for that graph. So not a function. I have two -2s. One matches with the 7, one matches with the 10. I can't have two different birthdays. Not a function. Here, I have 3 1s for the x's, and they all have a different y. I can't have 3 birthdays. I would love to have 3 birthdays, because I love me my birthday week. But that won't work. Not a function. If it's a graph, something like that. Not a function. Because this x has a y up here and a y down here. You can't have one x with 2 y's. Not a function. Okay? So if on the graph, your x-axis only matches up with one y, it's a function. But if that x-axis has 2 different y's, not a function. Make sense? So what we're looking for is always look for that x. Is there only one y, one birthday, given to each x? So let's look at our work that we're going to do. Which of the following are functions? Explain how you know. So you're not going to just put function, not a function. You're going to tell me what evidence you have that shows you it is or is not a function. So let's look at our first one. Look at your x's and your y's in your table. Do you think that would be a function or not a function? What do you think, Claire?
A function.
How do you know it's a function, Claire?
Because there are different y's and different x's.
The x does not repeat. It's okay if the y's repeat, it's okay if the y's don't repeat. We're looking at the x's. That's what will tell us if it's a function or not a function. So it's a function because the x does not repeat. So the next two tables you're going to look at and determine, is it a function or not a function? And you have to give your reasoning. Why is it a function? Why is it not a function? Then we have some word problems. Let's look at that first word problem. 3 ordered pairs of relation are 4, 8, -3, 6, and 5, 10. Write a 4th ordered pair that will make the relation not a function. So think to yourself, what do I need to put for an x? Because we're limited, what do I put for the x that would make it not a function? You're going to do it yourself, think it through. What do I have to put for the x, and then what can I put for the y? The next one says 4 ordered pairs of a relation are 0, 6, -2, -5, 3, -5, and -2, 4. Which ordered pair should be removed to make the relation a function? You're going to decide. We'll talk about it tomorrow. And then it says a game show has you randomly select a number that corresponds to a prize. If you select 4, you get a puppy. If you select 7, you get a scooter. If you select 11, you can choose between a taco and a trip to Hawaii. Does this situation represent a function? Why or why not? So think about the prizes, those numbers and the prizes in the terms of X's and Y's. So your numbers and your prizes, X's and Y's. Is it a function or not a function? And explain it. Are there any questions on this objective? Michael? What kind of face are you giving me at the end of the lesson? I like the snap and the thumbs up. Once it's explained, it makes sense. We learn these goofy new vocabulary words and we go, I have no idea. But we listen through the explanation and it starts to make sense. But if you still have questions, always come ask me. We have more time to figure it out. If you are watching this at home, I hope you are well, and I hope to see you soon. Have a wonderful day.